What's up guys, hope you all are doing great. In this video right here, we'll be creating a Caesar Cipher algorithm for encryption and decryption. So you know what, let's get started. Caesar Cipher is one of the oldest and the most common known cryptography techniques, and it was used by Caesar himself, hence the name Caesar Cipher. And the cool thing is if you're getting into cryptography, this is a great place to start. So this is what we're using. This is for educational purposes only, for you to understand the algorithm, for you to understand code better, and just get into cryptography. Another question you might have is, what is Caesar Cipher based on? It is based on a substitution cipher, where each character is shifted by a specific number of characters, which is the key. Now, before we dive further into the algorithm, I want us to understand some basics. And the basics are the terms in cryptography. One is the plain text. The plain text is the original message which is sent by the sender to the receiver. The next one is the ciphertext, and the ciphertext is obtained when the encryption algorithm has been applied on the plain text. So basically, it's the scrambled form of the plain text which cannot be interpreted without a key. Now let's talk about encryption. Encryption is the technique that we use to convert the plain text to the ciphertext. Now we get to decryption. Decryption is the technique we use to convert the ciphertext to the plain original text. Now, finally, we get to key, and key is the value that when we give it to the encryption or the decryption algorithm, it gives us the ciphertext and the plain text. Okay guys, what you need to understand before we start coding is that the Caesar cipher is dependent on the key selected. Each alphabet in the plaintext will be shifted by an amount equal to the value of the key. Okay, let me give you an example so we really understand this. If, for example, we have a plaintext of A, B, C, D, E, and we have a key of 2, what happens is that A will then equal to B, B will equal to C, D will equal to E, and E will equal to F. Therefore, the ciphertext will be BCEF. And now that we know this, let's code along, guys. We'll start this with a function called Caesar Encryption. And this function right here will take a plain text and also a key. After that, we'll create an empty string called encryption underscore str, and it's going to be empty. Now we're going to loop through I in plain text. So now what we'll do is that for checking the upper and the lower case, we'll use the isUpper and the isLower function for actually doing that. And this is where we write it. We'll say if I dot isUpper, what we'll do next, guys, is we'll use the odd function to obtain the Unicode point representation of the letter. So let me show you how we do that. We'll create a variable called temp. We'll set that equal to 65 plus inside here, then we'll say ord, and we'll put I inside minus 65 plus the key. Then we say modulo 26 because of the 26 alphabets. Now guys, what we're going to do is we're going to use the char function to actually obtain the alphabet from its Unicode integer value. So let me show you how we do that. We say encryption str is equal to encryption str, then we concatenate it to char with the temp variable. So now we've done this for isUpper. So we'll do exactly the same thing, but we'll do it for isLower. And the way we do that, we'll say an elif I dot isLower. I'm just going to copy this here, but we'll change some things inside. For isLower, in this case, we're going to use 97, and I'll tell you why we use 97 in a short. And basically the same thing right here. Then we create an else encryption str is equal to encryption str plus I. So what we'll do next, we'll say we'll print actually the ciphertext is, and then right here we just add encryption str. Now let me explain what we just did right here. Now I'm sure you're asking yourself why we're using 65 here and why we're using 97 here. Let me explain why we're using 65. Why we're using 65 is that the uppercase alphabet starts from the Unicode value 65. So A is 65, B is 66, and so forth. Similarly, the lowercase alphabet starts from 97, with the small letter A being 97, the small letter B being 98. So what we needed to do is we needed to subtract 65 and 97 for the uppercase and the lowercase characters, respectively, to reduce each alphabet to be A equals to 0 and B is equal to 1. And we do this till we get to 25 because we have 26 alphabets, but as we know, computers start counting from 0 while we start counting from 1. So that's why we have 26, and for the computer, it's going to be 25. And finally, what we just do is we use this formula right here, and the formula says C is equal to, and we put it in brackets, P plus K. And then we do modulo 26, which is the number of alphabets we have. And then we add 65 for lowercase and 97 for uppercase for that value to get the Unicode integer value that is obtained from the ciphertext. So that's what we did to get all this working. Hopefully you understand it. I'll leave some documentations if you don't understand it so you can check that out. Now guys, the final touch is actually asking us for the user input. So in this case, we'll say plain text equal to, then we ask the user for input, which is enter the plain text. Just copy this. The next one is the key. And as we know, the key is an integer, so we need to convert this to an int because user input is always a string. And you enter your key. And finally, we call our function because a function is useless without calling it. We say plain text and key. So this is it. Now we can actually create our message. Now the message is going to be, don't forget to subscribe and like the vid, guys. Now it's asking for our key. In our case, I'll put 10. And this is right here our encrypted message. All you need to do is give this to whoever you want it to actually decipher it, and you also give them the key, which is 10. Now I'm going to show you, which is very similar, the code to actually decipher this message. What I'll do first is I'm going to copy this, or I'll leave it right here. Before I rerun the program, I'll make sure that I copy it and paste it so we can actually see it decipher it. Okay guys, and now I'm going to paste the code for actually deciphering it. So this is it right here. And what I'll do is I'll explain it so we actually understand what this decipher code is doing. Okay, so we can see the whole thing right here. And what we have right here is we have a user-defined function named Caesar Decryption, which takes the ciphertext and also the key as the argument and prints the plain text. Now what you'll notice here is we have a zero-length string called Decryption str, with which we'll actually concatenate the plain text. Now guys, apart from the formula, the only slight difference here is that both the uppercase and the lowercase if statement, we're checking if the c minus k value is negative. Is negative or not from this formula right here, which is p is equal to, in bracket, c minus k. So this formula is very similar to what we had earlier. And then we say the same modulo 26. And if it is negative, then we'll add 26 to it before actually performing the modulus operation. And if it is positive, then we'll refrain from doing that and just encrypt the algorithm. So right now, let's actually test this. I'm going to copy this, and I will also comment out this right here. Now we run it. It asks for the code. This is it right here. And the key was 10. I can see here our code is right here. Don't forget to subscribe and like the vid, guys. So we see we get the same exact thing. And if you're interested in the code, down in the description you can find it. If you enjoyed this video, please like, please subscribe if you're new, and I'll catch you on the next one.